this video will look at the index law for division. Okay, so just a reminder that we're looking at indices, and in an index we have a base and we also have an index, or what's known as the power. Remembering that x is the same as x to the power of 1, x times x, x to the power of 2, and that so that means that the index tells us how many times x is multiplied by itself. Okay, so just like we did when we did it for multiplication, when we're looking at division, the way that we're going to come up with our index law is exactly the same. So what we're going to do is we're going to write this expression in expanded form. So we have 2 to the power of 5 on the top, so 2 multiplied by itself 5 times, and we've got 2 times 2 on the bottom. Now here it's important to remember that when you have any number divided by itself, it is 1. So 2 divided by 2 is just 1, so we can cross that out and replace it with a 1 on both the top and the bottom. I've got another 2 divided by another 2, which gives us another 1, and another 1 on top. Okay, so we've got 2 times 2 times 2 times 1 times 1, so that's just the same as 2 times 2 times 2, because before we had 1 times 1, that's just the same as 1, and so we can just write it as 2 times 2 times 2. Now if we were to write that in index form, we get 2 to the power of 3, and again we're looking for a relationship between the powers of our original expression. So see if you can think about what it might be. So in the same way, we're doing it for x. So we get x to the power of 3 divided by x to the power of 1. I'm going to write it in expanded. And we can again cross off this and replace it with 1 on both sides. So we end up with just x times x, which in index form is x squared. So again, we're looking at the powers and seeing, is there a relationship that we can see that is consistent? Because remember this, when we're thinking about a mathematical law, then it needs to be able to work every single time. So if we have a look at both of them, we can see that we've got 5 and 2 here. We're doing a division, remembering that division is the opposite operation to what multiplication is. And when we multiply, we're adding the indices, and so it makes sense that when we divide two indices with the same base, that we would subtract the powers. So our index law for division is a to the power of m divided by a to the power of n, which is the same as writing a to the power of m minus n. So m minus n just means that they can be any number, and they could be different numbers. Alright, so this is a section where I'm going to show you what to do. Okay, just subtracting the powers. 3 minus 2 is just 1. Y to the power of 21 divided by y to the power of 15. I'm just going to do the exact same thing with that. 21 minus 15 gives us y to the power of 6. Okay, with C, it's just a little bit different. The first thing I want you always to do when you see anything in algebra written like this, I want you to rewrite it in fraction form. So to rewrite it in fraction form, we just write the first expression goes as our numerator, and the expression that comes after the division sign is our denominator. Now, really important here that we remember that index laws only apply when we have indices with the same base. Now, notice here that we've got 24 divided by 8, so you can just do that in the calculator. That will give you 3. We've got g to the power of 3 minus 2, and h 6 minus 1, and that gives us 3 g h to the power of 5. Okay, so this is a chance for you to go through and have a go at them, so you need to pause the video, have a go, and then I'll go through and explain how to do them. Alright, so 10 to the power of 4 divided by 10 to the power of 3. Remember, we're just subtracting the powers, and so we get 10 to the power of 1, which is just the same as 10. K to the power of 7 divided by k to the power of 3. Subtract the, so 7 minus 3, and we get k to the power of 4. Alright, for C, the first thing you need to do is divide 32 by 8, and then go through, and for all the indices with the same base, make sure you're subtracting the powers. And that results at 4a squared c to the power of 3 and e. Alright, D, pretty similar to the last one that we just did. Okay, but this time we've got 42 divided by 4, g to the power of 16, divided by g to the power of 4, j divided by j, and e to the power of 12, divided by e squared. Okay, so here we're going to do 4a to the power of 16 minus 4, so you get 4a squared e to the power of 10. Now notice here that we don't have a j term, and the reason why we don't have a j term is because when we have any base with the index of 0, then it's just 1. And we can see that here we've got j divided by j. We know that any number divided by itself will be just 1.